Lesson 11 for Year 13 Physics. It's on transient current and voltage in a resistor capacitor DC circuit. So what do we have here? So I've got a circuit here which has got like a two-way switch, and there's a capacitor, a resistor. Resistor is to limit the current, and here's your supply. So when you close the switch and it's in position S1, the capacitor is going to get charged, and the voltage across the capacitor plates will start to increase until the voltage finally of the capacitor becomes equal to the resistor voltage, to the source voltage, and the current will stop. So if you drew a graph of voltage against time for the voltage across the capacitor, you will have an exponential growth curve. So at any time in this charging process, the voltage across the resistor is equal to the supply voltage minus the voltage across the capacitor. Now, while the capacitor is being charged, initially the current is a maximum and it reduces to zero once the capacitor is fully charged. So a graph of voltage of current against time is an exponential decay curve. So when you're drawing this curve, just make sure the line doesn't actually touch the x-axis. It only gets closer and closer to it. It's an asymptote. Okay, then when a capacitor is being discharged, and in order to do so, the switch is moved from position S1 to S2 so that there's no longer any supply voltage. So the charged up capacitor is now going to discharge through the resistor. And when that happens, the charge, whatever charge is accumulated on the capacitor plates, is going to get out of it. So the voltage across capacitor plates will drop down to zero. So here's your decay curve, and when there is no longer any voltage across capacitor plates, the current will be zero. So the current is very high at the start and it falls down to zero. Again, these are exponential decay curves, so your line should not actually touch the x-axis. So we have something called the time constant, and it is the time it would have taken to fully charge or discharge the capacitor if the rate had not changed. So what does that mean? If the rate was the same as here, it would have actually got charged in this time. Okay, so that is, if you look at it, it's actually about 63% of the total voltage or current, and it's calculated using tau. Time constant is R times C. So that's what the time constant depends on. And in reality, it takes about 5 time constants for a capacitor to be fully charged or fully discharged. So one way of calculating the current or voltage at any time constant is to go in steps of 63% of the total voltage or current, or the other one is to use an exponential equation. So for a growth curve, the voltage at any instant is V max 1 minus e to the power of n, and for a decay curve, which is always the current, or it could be the voltage, is I max e to the power of n, and e is your exponential button on your calculator. And I hope that helped.